communications will occur around 300 miles over the horizon due to tropospheric scatter. As seen here. So we got cool, dry air here, right? It's an inversion layer. We got cool, dry air here, and we got moist air right inside here. And if that little duct happens to be where you are, and a radio like this, I could get 300-400 miles away. The guy who puts out this book, Gordy West, he puts out all the questions in his book. He's known for doing this kind of stuff. And he lives down in Orange County, right near the water, but up on a hill. And he has a buddy that lives in Hawaii, 3,000 miles away. And they have actually done this using these frequencies, but with a little bit more power, over 3,000 miles. He's kind of like an addict in that. Tropoducting is what it's called. Okay? So tropoducting is caused by temperature inversions, and we have a lot of that here. Now, obviously, it typically happens where there's water. It doesn't happen over the dry land. Okay, meteor scatter, aurora, reflections, and polarization. So this is a bunch of miscellaneous stuff. Some of this you just have to memorize. It's the best band for meteor scatter is the 6-meter band. Just memorize that. There's a 50 to 54. Different subject. The characteristic of VHF signals received via aurora reflections is that these signals exhibit rapid fluctuations in strength and often sound. Does anybody know what an aurora reflection is? An aurora is. That's because you live down here in California. When you live up closer to the North Pole, or if you live close to the South Pole, several times a year, the Earth has this big magnetic field that goes to the South Pole, right? Big magnetic field. Well, certain times of the year, at night, when I lived back in New Hampshire, you look up towards the North Pole and there would be funny purple lights up in the sky. It would be like someone was just lighting up the sky with these purple lights. And that's called the aurora borealis. It's very, very common once you get up into Canada, northern New England. So this is the aurora. Okay, so what happens if I'm operating my radio and there's an aurora? Oh, what it's saying is the characteristics of these signals received via an aurora reflection. So if the signal bounces off the aurora, the signal would sound to you like it's rapidly fluctuating in strength, but the sound would be distorted. That's all. Okay. Here's a different one. When a radio wave leaves the antenna, it typically has a certain polarization. The radio wave leaves this, it's polarized. What does that mean? Well, if the antenna is like this, the radio wave comes off like this. If the antenna was like this, the radio wave comes off like this. That's called polarization. We'll talk about that more when we get to the antenna section. But if that radio wave reflects off the ionosphere, the polarization changes. So let's say that I had enough energy for this to go up on the ionosphere. And it goes up, goes up, goes up. But once it hits the ionosphere, it changes. Memorize that. Nothing to memorize. There's no question. Information. This change in polarization can be referred to as an effect of skip reflections between the Earth and the ionosphere. Memorize that. Get all that technical stuff here. Okay, technically, at this point, we've only covered now half of the questions. We've now covered half, okay? We still have half to go. So let's jump to 11. And 11 is where I should have been 2 sessions ago. Not this session, 2 sessions ago. Okay, talk to outer space. Amateur radio operators can have a radio in a space station. Yep, believe it or not. It can be an amateur radio station in a space station. Now, it says here in the FCC book, Part 97, defines that space station as an amateur location that's more than 50 kilometers above the Earth's surface. That's 31 miles. They like to talk in kilometers. 31 miles. So a space station can't be something located on Palos Verdes. It can't be something located in an airplane in the 747 that's flying over there because that ain't high enough. It's got to be something that's at least 50 kilometers above the Earth. That's a space station. An amateur holding a technician license may contact an amateur station on the International Space Station, okay, using the 2-meter band or the 440 megahertz band, okay, the 70 centimeter band. So, yep, we're actually allowed to talk to one of the hams who might be on the space station when they decide to talk to us. Okay? So what the FCC has set up is what's called satellite subbands, a little narrow spectrum, where if I want to hear if there's a ham in the space station talking, I just have to turn to these frequencies. He's not like everywhere, he's going to be in these frequencies. So they're satellite subbands are a portion of the band where the satellite operators are permitted. So a satellite subband on the 450 megahertz band would be these exact frequencies, 435 to 438. So if I just tune between those frequencies, and I know there's a satellite up at a space station with hams in it, I can listen there to see if they're talking to anybody. Now, what's the other problem? That space station is running around the Earth. Every 90 minutes it goes around the Earth. So if it's on the other side of the Earth, I'm not going to hear it. I'm only going to hear it if he's operating. I'm only going to hear it when he's visible to me, technically in my line of sight, so to speak. Once he goes over the sunset or horizon, I don't hear him anymore. Okay, so the satellite is in mode UV, whatever that means. The uplink is in the 78 megahertz band, the downlink is 2. Okay, let's just explain this. UHF, VHF. This is the 440 megahertz band. This is the 2 meter band. So at certain times, apparently, when we talk to satellites, when we transmit to them on this band, and they listen to us on this band. That's called a UV mode. Just memorize that. Okay. But there are actually satellites in here that have repeaters in them, believe it or not. Because you remember we said some of these frequencies go right through the ionosphere, right? Straight through. Now if I get enough power, I could reach a satellite if I had enough power. It is line of sight. So there's called AMSATs, the Amateur Satellite Corporation, and they coordinate and build and launch most of the amateur satellites. And right now there's over 15 satellites in outer space that got repeaters in them. They're amateur satellites. So we can use amateur satellites to talk to hams in other countries. Well, okay, think about this. If the curvature of the Earth was just right here, and I'm looking east way up in the, a couple hundred miles up to an amateur satellite, or whatever, how far up he is, 1,000 miles. Well, gee whiz, that would be the line of sight back to maybe Europe or England. So if that satellite's in the right spot, I could be talking to someone far, far away, or someone just down the street through the satellite. Okay? You would need a satellite tracking program. What's that mean? Well, I have to have an antenna that points at that satellite. It ain't going to be one of these things. It's going to be an antenna that directs my energy in one direction. Well, what direction? I have to know exactly where the satellite is. So I have to have a program in a computer that says your antenna has to be pointed, and I have to send that information to my antenna. My antenna has to have a device that will keep it pointed where the satellite is all the time. So that way I have the best signal there. So you would need a satellite tracking program to know where the satellite is and when you can access it, line of sight. Because once that satellite goes beyond the curvature of the Earth for me, my signal can't see it no more. It's gone. It says, there's things that says, use the minimum power needed to make contact. Well, that's kind of a joke, that third question, but this is a very little power, 5 watts. There's no way you could talk to that satellite with these 5 watts. It just ain't going to work unless you had one enormous antenna. So this is kind of a joke with that question they have. Spin fading refers to the satellite signal when the satellite and the antennas are rotating. The signals rise and fall. And what does that mean? A lot of satellites, they spin when they're in the air. Spin, 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 spin. Well, but their antennas have to keep looking down towards the Earth. So the satellite's spinning, the antennas, but it tries to have these little motors that keep the antennas looking down. But once in a while, the antennas don't quite look all down. So the signals that we're transmitting up and down will be strong, weak, strong, weak. That's all we're talking about. Spin fading. That's what we memorize. So this one's a little ornery here. Here's the Earth, and here's, let's say, where I am. Here's a satellite rotating around the Earth. Okay? So here it is, and it's coming this way. So the amateur satellites travel around the Earth in an orbit which is called LEO, Low Earth Orbit. Okay? Memorize that acronym. As the satellite comes closer or goes farther away, there is a Doppler effect. What does that mean? So I'm going to give you an example. if he was standing someplace and a train was coming, it would go. Why did the tone change? Or even if it's a car. Why did it go from a high pitch to a low pitch? Because when a sound is being generated, let's say by the car, and it's moving in my direction, the audio wave that it creates is kind of getting shorter. It's compressed a bit because the car is moving in the same direction as the wave that I'm going to hear. What happens when a wave gets shorter? The frequency gets higher. Ah, remember that? Now, once that car passes by me, it's still creating a noise, an audio wave, but the car is moving, and so the wave tends to be longer. When the wave gets longer, the audio gets lower. Right? So guess what happens? I want to listen to this satellite on a given frequency. But as this thing is moving towards me, the frequency that's operating on, when I receive it, sounds a little higher as the wave gets shorter. So the frequency I listen to it is a little higher. Once that thing passes by me, that frequency wave sort of gets a little longer, and the frequency gets lower. Perfect. Okay? So as the satellite comes closer or goes away, there's a Doppler effect. So the Doppler shift creates an observed change in the signal frequency we see caused by the motion between the satellite and the Earth. So remember they said these satellites, stations operate on 435 to 438. Technically he's probably dead center, but when he's coming in, his frequency is more towards 438 higher, and as he's going away from me, his frequency sounds a little lower. That's what that's all about. That's the Doppler effect. Long answer for you. Okay, more space station stuff. The satellite beacon is a signal from a satellite that contains information about the satellite. So there's people who use the satellite, and there's people who operate the satellite. So there's people who make sure the satellite is in the right place, it's doing the right thing, it's not getting out of orbit. Well, how do they talk to that? They have computers, and they have what's called a beacon transmitter. So a beacon is how the owner of the satellite talks to it to keep it under control. Okay? Part 97, this little guy right here again. The Part 97 definition of telemetry is one-way transmission of measurements at a distance from the measuring instrument. This is very vague. Just memorize that answer. Telemetry is the method for talking for this guy to go and talk to the satellite. About that, just memorize the answer. And basically, as a person operating the satellite, I can send it a message, a telemetry message in zeros and ones, and tell it what to do. I can send a message what to do. So it's a one-way transmission, okay? But it's legal. Okay? Using this one-way transmission from the satellite downloads status of various parameters from the satellite. The satellite can give me a one-way message saying, here's where I am in orbit, or here's what I'm doing here, or here I'm getting out of fuel or something. Okay, Part 97 defines telecommand as one-way transmission to initiate or modify, terminate functions at a distance. So what they're saying here is telemetry is satellite talking to me, and telecommands is me talking to my satellite. That's all I got to do. We don't need to get into this. Let's just keep moving. Oops, great. Do you have any time left?
It's 8:15 right now.
8:15. Okay, we start at 11 next time.